All right, boys and girls, I'm going to go through a couple of these problems. Hopefully this will help you review for the test on Friday. Okay, out of the graphing ones, I'll do number 2. So first thing we always want to do is factor. So let's factor that. Let me pause and go shut the door. All right, door shut. Here we go. So factor this. Multiplies to get -8, adds to get -2. So remember, multiply, add. Now, that's hopefully is an easy one. We need a -4 and a +2. Okay. Next, let's factor this. Add to get +3, multiply to get +2. Again, hopefully another easy one. All right, then from here, I see I could cancel these out. So I'm left with x minus 4 over x plus 1. So now to figure out the whole, I'm going to take what I canceled out, set it equal to 0, solve for x equals -2. So now remember, a whole is a point on the graph where the graph does not exist. So if it's a point, I need an x and a y. If I already have the x, to find the y, I need to plug it in. So, oops, my bad. So then we're going to do -2 minus 4 over -2 plus 1, which gives you -6 over -1, which gives you +6. So my whole is at -2, 6. And I can graph that right now. -2, 1, 2, 3, 4, 5, 6. So there's my whole. Perfect. All right. So VA now, remember, is when the function is undefined. So for a fraction to be undefined, we need the denominator equal to 0. So just set what's left equal to 0. Boom, boom. All right, so x equals -1. Piece of cake. So now, on x equals -1 is my vertical asymptote. Perfect. Okay, so horizontal asymptote, we are comparing the exponents in our numerator and denominator. You can use the simplified version or the original, doesn't matter, should be the same answer. So here we have both exponents of 1, so we're going to divide the leading coefficients, so 1 over 1 equals 1. Our horizontal asymptote is the line y equals 1. All right, not bad. Okay, so zeros and x-intercepts are the same thing. So now what we're going to do is set our numerator equal to 0, because remember, if the fraction equals 0, it doesn't matter what the number on the bottom is, just the number on the top, which is the numerator. So x minus 4 equals 0, x equals 4. So this is my x-intercept at 4. Perfect. Okay. Y-intercept. That's when the x value is 0. So for the y-intercept, I already know that the x value is 0. I just have to figure out the y. So I'm going to plug this into my simplified version. So we're going to do 0 minus 4 over 0 plus 1 and equals -4. So my point is 0, 2, 3, 4, -4. Perfect. Alrighty. Now, domain. The domain is going to be from -infinity. Now, we're going to go all the way over till we hit our first interruption. So our first interruption in this case is our whole, and our whole is at -2. So then we're going to do -2. Union, -2 to our next interruption, which is right next to it, at -1, which is our vertical asymptote. And then from -1, it goes on forever. So -1, forever. Wonderful. Okay, now let's graph this bad boy. So I have 2 points here, and I kind of know that these lines are going to ride the vertical and horizontal asymptotes. So let's just get one more point in the middle just to make sure you can kind of see how it curves. So let's do 2. So say I have x, y. I want to find out the value at 2. Again, plug this into the simplified version. So 2 minus 4 is -2. 2 plus 1 is +3. So at 2, I'm at -2/3, which is roughly right there. Okay, so again, we're not going to be perfect. It's not going to be exact. This is just a sketch. So I'm going to right here, turn there, boom. Perfect. All right. So on the next one, I have a point here at -2. So let's try -3. So -3 and -4 is -7. -3 and +1 is -2. And this equals positive roughly 3.5. So at -3, 1, 2, 3, I'm at 3.5. 1, 2, 3.5. And just to make sure, we'll do one more. How about we do, that's 1, 2, 3, 4, we'll do -5. So at -5, -5, and -4 is -9. And then -5 plus 1 is -4, which equals positive 2.25, 2 1/4. So 1, 2, 3, 4, 5, 1, 2, and 1/4. So this is probably going to look something like this. Okay, there's our graph. Clearly a hole here. Actually, what color is the hole? We did black, so the hole is clearly here. The line jumps over the hole. That's undefined. My vertical asymptotes, points, perfect. This is what your work and graphs should look like on the test. All right, keep it moving. What else is down here? Okay, so I'll do 1 or 2 from here. So hopefully we can all simplify something like this already. I'll do it quickly, but hopefully we can do something like this. So basically, you break it up into different things. So numbers first. 18 divided by 12, I could simplify into 3/2 by dividing the top and bottom by 6. The next thing, x to the 6 over x to the second. Remember, that's 1, 2, 3, 4, 5, 6 over 1, 2. Cross them out, I'm left with x to the 4th. Or you just think 6 minus 2 is 4. And then finally, the y's, there's 1 up top, 5 on the bottom. So if I subtract, I'll get 4 on the bottom. And there's your answer. Okay, so next thing, remember I said in class that this should be a 2. So now another way to factor and simplify is the GCF. So I could take out a 6 out of here. I'm left with x minus 2. I could take a 4 out of the bottom. I'm left with x minus 2. So because this is multiplication here, connecting these two quantities, I could simplify this. So that's gone. And then the 6/4 just becomes 3/2. Done. Then finally, one of the last ways you're going to have to simplify is by factoring. So we're multiplying for -10, adding for -3, x minus 5, x plus 2. Okay, so this one's a little hard. I'll have to slide divide bottoms up. So I'm going to go x squared minus 9x minus 10 when I slide, sorry. So then I'm going to factor, multiply to get -10, add to get -9. But don't forget, I need to do the slide divide, bottoms up part, we always forget. divide by 2, divide by 2. This simplifies to x minus 5. And this simplifies to 2x plus 1 because this does not go in evenly. So the 2 has to come up. X minus 5. 2x plus 1. And again, you should be getting something to cancel out. If you don't, you should go back, double check just to make sure. But that is gone. Done. This is your answer. Okay. So again, multiplication, same thing. We can simplify vertically and diagonally. I'll do this one. This should be a 15 here. So this part you'll have to factor. X plus 3, x plus 2. This part stays the same. 4x squared. This stays the same. 6. This stays the same. Well, actually, this I could factor with a GCF. Take out a 5. X plus 3. So here we did factoring and GCF. Multiplication. So I could simplify diagonally. Those are gone. I could do this diagonally. 2 goes into 4 twice. 2 goes into this 3 times. And I'm left with 3x plus 2 over 10x squared. Done. Keep it moving. So it looks like there's no division on here. Actually, now I'm going through it. So just remember, with the division, it's the exact same thing as multiplication, but you have to keep the first thing, change the division to multiplication, and flip the second fraction. Just remember about division. Okay. Common denominators. Best thing to do is to find out what you're missing. They all should be the same thing. So here, I'm missing an x plus 5. And so I'm going to take this and multiply it by x plus 5 over here. And I'll do the same thing up top. So now my common denominator is x plus 5 times x plus 1. I'm going to leave it like that. And then you multiply this out on top. 3x plus 15 plus 4x. Simplify. 8x plus 15 equals x plus 5 over x plus 1. Boom. Oh, where'd that go? There it is. Okay. Ooh, got 2 minutes left before this thing runs out. So be careful with subtraction. Make sure you're distributing the subtraction sign to all terms. That's just a cheat way to solve. Remember, with solving, the goal is just like adding and subtracting, except once you get common denominators, this is the only time you can then cancel them out. And then you're just working with the numerators. So this would be 7x equals negative 21, x equals negative 3. It's the same thing as adding and subtracting, except it gets easier because once you get common denominators, now you can cancel them all out. So these ones here, you're basically creating your own. So if I need a vertical asymptote at x equals 4, that means in my denominator, I need x minus 4. If I need a horizontal asymptote at 2/3, that means that I need the same exponent, so I have to divide the leading coefficients. So now it's the same exponent, and the leading coefficients should be 2/3. Here, I have write an equation of a rational function has no horizontal asymptote and 2 vertical asymptotes. So 2 vertical asymptotes would be this, and no horizontal means my number, my exponent on top has to be greater, so that's just this. Boom. All right, and then this problem, the word problem is pretty self-explanatory. It's just a vertical asymptote at 10. The hard part is the context of the problem. If there's more than 10 cars per minute, traffic is stuck. We're not going anywhere. So that's it. I have 3 seconds left. Hope this helps, and fill out that form.